We are almost there. We're just about to create our first IPsec VPN. There are 5 overall steps to this build, and a quick word to the whys here. If this is your introduction to VPN terminology, or it's been a while and you're a little rusty, don't let it intimidate you. It just takes a little getting used to, because we've got 2 policies to build. We've got a crypto access list to write. We got a couple of other things we got to do. So a lot of little details here, which is why I like to have a checklist in mind when I'm going to write one or troubleshoot one. And the first step of the VPN build is the process initialization. And we don't want just any traffic triggering a VPN build, or we're going to have a lot of VPNs, we're going to have a lot of overhead. So what we're going to do is write a crypto access list to define what we call interesting traffic. That's the traffic that will actually signal to the VPN device, in this case a couple of Cisco routers, that it is indeed time to get to work. I do not choose to configure the crypto ACL first. This is the first step in the build, but I like to get my policies taken care of first. That's the order we're going to take this in. So we're coming back to the crypto ACLs. Be sure you have these 2 phases totally clear in your mind as to what goes where and what's going on with IKE phase 1 and IKE phase 2. They're both negotiations. The first one, this is where the, take a deep breath, Internet Key Exchange Security Association is negotiated. And that's what we call an IKE SA, and that's what we'll be calling it from here on out. When this phase is successful, the result is one bidirectional IKE SA. As opposed to what we get at the end of IKE phase 2, there is a negotiation here, but what we're negotiating here is the IPsec Security Association. So if you say it out loud, it's all the way, it's IP Security Association. Let's just call it IPsec SA. Now when phase 2 is successful, what we end up with is 2 separate unidirectional IPsec SAs. Now of course the big thing to be concerned with here is if phase 1 is not successful, there is no phase 2. So we got to watch our P's and Q's when it comes to that phase 1. Now finally, and just popped up on the screen there, the data transfer is our middle section, and that's where the data is transferred, but you knew that. So we've got the VPN built, we've got our policies negotiated, we have the actual exchange of data, and then we got to tear that VPN down, because once it's no longer in use, we don't want to spend the overhead, we don't want to use the overhead to keep it up. Now, we can configure the tunnel to be torn down at a couple of different times, one of them being when a certain amount of data has gone through. You can also configure it to be torn down after the tunnel has been idle for a given amount of time. We'll see both options here shortly. Now, of course, the first question I had when I read about this the first time was, well, what happens if I'm sending traffic through the tunnel and the tunnel's supposed to be torn down? That doesn't sound good. Well, what can happen, and what will happen there, is that a new SA can and will be negotiated on the fly while the existing SA is still in place. So we're still in good shape if that's what happens. Now we're going to get to the fun stuff. We're going to start configuring. And in this lab, we're going to build a VPN between routers 1 and 3. There's a shared channel between them, frame relay to be exact. And just to show you here, let me go ahead and slide that over a bit. I will send a ping over to 172.12.123.3. Now that's slightly off the screen. I will bring that up. And we're in good shape. So we're using the 172.12.123.0/24 subnet, routers 1 and 3 communicating over frame, no problem at all. And we're going to concentrate our config, or get started actually, on router 1 with these 5 values. And as we go along, we're also going to discuss why you would pick certain ones here of encryption and the hash choices we're given, and also why you might not want to choose others. And also, I will upload a Cisco document. Instead of giving you the link, I'd rather give you the document because the links change. It's some information that's the source for the information you're going to see here, and it's well worth your time perusing it before you take your CCNA security exam. So let's dive right in. With authentication, we're going to do pre-shared keys. With encryption, we're going to do something called 3DES. Every once in a while, you'll see this called TDES for triple DES, but generally it's 3DES. Hash, we're going to use something called SHA, which I like to pronounce SHA. Lifetime, 24 hours. That's the config we're going to put on router 1. That's how long we'd like our phase 1 SA, IKE SA to last. And something called the Diffie-Hellman group. We're going to go with group number 5 here. Let's go ahead and bring up the live equipment, because first things first here, we have to make sure that everything is on that should be on. So let's run a little command, our first show command, show crypto ISAKMP. And you better get used to this one because this is the show command, obviously, for our phase 1 info. And what we're going to do is go with policy. And you might say, well, hey, we haven't configured anything yet. Well, we haven't, but there will be a default protection suite here on the router or your VPN device. And there's your default protection suite. We have not configured one yet. And you see a value for each one of the 5 categories I mentioned: encryption, hash, the authentication method, the Diffie-Hellman group, and the lifetime. Notice the lifetime mentions seconds and no volume limit. Remember that. It's good stuff to know. What we want to do, though, is configure a policy that goes along with the values that we had on the board. And let's go back to that. Pre-shared keys, 3 DES, SHA for the hash, 24-hour lifetime, and a Diffie-Hellman group of 5. So since that does not match up what we've got here, we've got to create our own policy. That's what we want to do anyway. So the command for that is crypto ISAKMP policy. And then we're going to put the priority of the protection suite. I'm going to address what these priorities mean and when they come into play, but note that you have to assign one. There's no option for don't give it a priority. It's got to have one. And we drop into ISAKMP policy configuration mode, and now we'll look at our options from there. And you can see it even mentions to us, pardon me, the ISAKMP commands. That's nice. So we've got authentication, we've got encryption, group hash, and lifetime. So they're all there, along with the other usual suspects of default, exit, and no. Let's look at our options for authentication first. And we've got a couple of RSA options here. What we're going to do for this lab is you use pre-shared keys. And you'll notice there's no option there. So that's great. We're going to have pre-shared keys. Where are they? Where do we set them? That's coming up. We have to use a separate command for that. Now we're going to choose our encryption. And here we have a 3 DES, which is what we said we wanted to use. We have an AES and DES, data encryption standard. Let's go back to the board for a moment because I want to discuss those 3 with you and what Cisco has to say about them. And also you'll see this information in the PDF that I left for you. DES, you know, it's easy on your router resources, but this is a very big but. It is the least secure of the 3. It was fine in its time, but it is no longer considered secure, and Cisco actually recommends that you actively avoid its use. Now, 3 DES or triple DES, it's very similar to DES in operation, but as you'd expect from the name, a block of data is going to be processed 3 times rather than once. And the word generally used to describe 3 DES level encryption is adequate. You know, it's okay. It's not great, but it's okay. Now, AES can be really great. The Advanced Encryption Standard, it's much stronger overall security than either one of the other 2 choices, but also it requires an iOS later than 12.3T to run AES, which in today's network shouldn't be any issue for you, either lab or production. But we're going to stick with 3 DES here. Now, I want to bring a couple of terms to your attention that, again, I say this often, you need to have these crystal clear in your head, which is which. Now, all 3 of these are what we call symmetric encryption algorithms because they use a single key that performs both encryption and decryption. That's opposed to asymmetric encryption algorithms, which use 2 keys, a public key and a private key, the public key used for encryption and the private key for decryption. So with all of that in mind, we are going to go with 3 DES here. And what else do we have? The hash choices. Officially, the full word is hash. I put has, so that was fine. Now we have that secure hash standard, SHA. And we have our old friend MD5. Remember MD5 from your CCNA studies? It's really one of the first encryption algorithms you run into. And not to badmouth MD5 right in front of it because I know it's sitting right there, but I mentioned this in your CCNA studies, so I'm going to mention it again here, and Cisco does as well in their documentation. You got to watch the use of MD5 because especially the version of it that is used to encrypt passwords in your config, you know, when you run that certain command, remember service password encryption, well, that uses MD5. And what it's really good for is very casual attacks, or I should say defending against very casual attacks. MD5 is easily crackable. That's not just me talking. Cisco will tell you that. Their version of MD5 on the routers, you can pop it. You can find a program to pop it loose in less than 30 seconds, probably less than 5 if you know where to look. And so the problem is with MD5, of course, it's not particularly secure, obviously. It's good to prevent what we call the over-the-shoulder network attack. You know, when someone's in your room, your server room that shouldn't be there, and they look over your shoulder and say, oh, his password is CCNA. Well, it's good to prevent that, but that's about all I would really depend on it for. So here, we're going to take SHA. Now, with Diffie-Hellman group, my fault. With the Diffie-Hellman group, you're actually going to use the command group because as you saw, there was no Diffie-Hellman option when we looked at our options a few minutes ago. So here, different devices are going to have different capabilities here. And we would prefer a higher Diffie-Hellman group number than 5, but this is the highest this particular device is going to handle, so we're going to go with that. And the higher the number, the larger the modulus, and it is considered more and more secure. As a matter of fact, I think Cisco tells you really not to use group 1, even though it's still widely available. So let's go ahead and go with group 5 there. And lifetime. Now, I gave you a spoiler on this earlier. On the board, I broke it down into seconds for you. But let's say I came up to you and said, hey, I know you just got your CCNA security certification by taking Chris Bryant's class. I need you to set write the policy, and I need you to set the lifetime of it to 24 hours. That's a great job interview question. Someone comes in, just see if they know what they're talking about. Hey, write me an IKE Phase 1 policy. And if I asked you to write lifetime for 24 hours, what would you put right here? We're going to talk about that and continue this lab at the beginning of the very next video.